Hey there, this is a continuation of our study of the measures of variability. This is part 3 of that series of videos. So we're gonna now go on to Statcrunch and look at our data for the restaurant example that we have been doing. So if you haven't done videos 1 and 2, go back and do that. We are studying the restaurant data. So what you're gonna do is go to Statcrunch, go to My 11 Mastering via Canvas, and then click on Statcrunch from the left menu of your MyLab homepage. Then you're going to open Statcrunch and go to My Groups. So this time we're going to do things a little bit differently than before. Before we selected open data sets from our textbook. This time we're going to go directly to Statcrunch. So let me show you what I mean by that. So when you are in My 11 Mastering, right, so from here, from Canvas, you're going to go to My Lab and Mastering, click on Open My Lab and Mastering, and that will bring you to our homepage. So on the left bar, you'll see right underneath Gradebook, you should see Statcrunch. So when you click on that, it opens this little window that asks you view data sets from your textbook. So if you're doing homework, this is what you want to do. But we're just going to go to visit the Statcrunch website. Make sure that your pop-ups are enabled so that you are able to open a new window. So click on that and it will bring you to Statcrunch, and you should be logged into your MyLab to do that. And so it will bring you to the home page. Click on My Groups. And we are ARC Stat 300 Fall 22. If you haven't joined this group yet, then you want to go to Groups right here and just on the search box, search for ARC Stat 300 Fall 22. Make sure that Professor R. Owens is the owner, because that's me, and then you're going to be able to join the group. So go ahead and select the group, and then we have the restaurant receipts. So click on that data and our data pops up. All right, so let's go back to the notes to remind ourselves what it is that we're doing. So we are going to use Statcrunch to create a dot plot for the data. And when I compare it with our own dot plot. So let's go back to Statcrunch. And so here's my 10 items from the receipts for our restaurant data. And we're going to go to Graph and to dot plot. So Graph, dot plot. And we're going to select the column Restaurant Bill and just compute. And so here we have our dot plot. So compare it with the one on our notes and it should be the same, right? So notice they don't have all the numbers marked like we had. So let me go to that one. When we did it, where is the dot plot? I hope I'm not giving you a headache by scrolling so fast, but so here it is. So I started at 36 and we went all the way to 58. But notice that our dot plot looks very similar to the one from Statcrunch. So everything matches. Notice that that must be 42 with the 2 dots, and that must be 50. Well, that is 50. We can see that one. Now we're going to try to go to the rest of our data analysis. So let's go back to where we were. All right, so then now that we did this part where we compare our dot plot, let's go find the rest of the items, the statistics. So there are 3 ways to measure variability: range, standard deviation, and variance. So the range we already talked about is the difference in data values, and the way we find it is we do the maximum value minus the minimum value. The standard deviation, we already computed it by hand, is this formula, and the standard deviation is a measure of how much the data values deviate away from the mean. And the variance is a measure of variation equal to the square of the standard deviation. So notice that the formulas are very similar, just one does not have the square root. The variance does not have the square root because it is the square of the standard deviation. So that is the variance. Sometimes the variance is a good estimator because the variance is an unbiased estimator for the variance of the population. So the sample variance is an unbiased estimator, meaning that regardless of the sample, The sample variance will revolve around the population variance. Whereas I talked about earlier, the standard deviation is a biased estimator because each sample is going to give us a standard deviation that is an underestimate of the population standard deviation. So standard deviation is a biased estimator. A variance is an unbiased estimator. So sometimes we want, especially when we're doing statistical analysis, and we'll do that in chapter 6, we want to do statistics and statistical analysis with the variance. So how do we find it? So from Statcrunch, we'll go and do the summary stats for that. So on the notes that I provide for you, there's always instructions, directions on how to use Statcrunch. So to find here the mean, range, standard deviation, variance, and outliers, we will do, well, for the outliers, we'll do something else. But to find the mean, range, standard deviation, and variance, we will go to Statcrunch, and we are going to go to Stat, the Stat menu, then Summary Stats, and then Columns. And then once you're in the columns, there's only one column for this data, the restaurant receipts. So we're gonna click that column and then control and click the statistics that we want. So the statistics that we want are the mean, the range, the standard deviation, and the variance. So let's go to Statcrunch. When you go back to Statcrunch, you'll still have your dot plot. That's okay. Let's just close it out. And now let's remember our steps. So we're gonna go to Stat. So make sure you're in the Stat menu. Make sure you're still in the restaurant receipts data, just the one column with 10 restaurant bills. So let's go to Stat, Summary Stats, Columns. So Stat, Summary Stat, Columns, and select restaurant bill. If we had more columns, like last time when we did the carriers for airport data speeds, we had Verizon, AT&T, Sprint, and T-Mobile. So you will choose the one that the column that you want to do statistical analysis on. So restaurant bills, and then we are going to choose, what did we say? We wanted the mean. So notice the mean was selected. I also want the range. So in the order in which I pick them, that's how they're going to show. So range, but I want to do control, hold down the control key, and then click. So that's range. Then I want the standard deviation and the variance. So standard deviation and variance. So those are the four. The order in which they show here is how they're going to show in your summary stats. So click compute. And here is our results. Here are our results. So we have the mean is 45.4, which is what we had gotten. The range is 18, which is also what we had gotten, the maximum value minus the minimum value. The standard deviation, 5.56, that is what we got too. And so the variance is the square of the standard deviation. So if you take 5.56 and you square it, you're going to get the variance. So let's go ahead and copy this, and we can put it into our notes. So I'm just going to insert it right there. So the nice thing also about Statcrunch is that it allows you to do this, copy and paste into your notes. And oftentimes it will do what it just did here. It will include the link, but if you're taking notes like I am, you can just delete that, and there you go. So there's our mean, range, standard deviation, and the variance. And so notice that these three we had found by hand. Remember how we found the standard deviation in the prior video? That was this mad work over here that we did, finding the deviation, then squaring it, then adding them all up, and divided by 9, and then taking the square root. So that's how we found the standard deviation. But with Statcrunch, we just put the data into Statcrunch and we are able to find it. We've got the exact same value. Okay, but this doesn't quite help us with our outliers. So how do we find outliers? So we're going to go into a little more definitions. Percentiles and quartiles. So percentiles divide a data set into 100 equal parts, and quartiles divide our data set, an older data set, into 4 equal parts. So with percentiles, we can say about 10% of the data fall on or below the 10th percentile, and we denoted P sub 10. And about 20% of the data fall on or below the 20th percentile, and so on. So if I said your quiz score, you were in the 85th percentile in the recent quiz that you took, what does that mean, right? So that means that about 85% of other quiz scores fell on or below the 85 percentile, below your quiz score. So that's what that means. Quartiles divide the data set into 4 equal parts. So 1/4 is 25%, the second quartile is half, the third quartile, Q3, is 75% of the data, and so on. We don't really find Q4 because that's 100% of the data. So that is the whole thing. So the idea about outliers is that if they are beyond the third quartile, and I'll show you a little more what I mean by that, then we have an outlier. So let's find the quartiles of our restaurant data set. Now to find our quartiles, we really need to be able to find our percentiles. So if to find Q1, that really means the 25th percentile. So looking back at our notation here, right, Q1 is where 25% of the data falls, and so we denote it as P25. And so that's what Q1 equals. It gives us 25% of the data. So we're gonna look at the formula. We're gonna need a locator value. So let's let L be our locator. I call it the locator value. So what this does is it gives us the position of the value for a specific percentile. And so, for example, if L is equal to 3, this means this is the third value in our data set, in the ordered data set. Right, so if L is 5, that's the fifth value when you have put the data in order. And so when you say it's the position of the value for a specific percentile, the formula that we're going to use is L is equal to K over 100, right, percentile times N. So we already said what L is. What is K? K is the percent value wanted. So in our case, we want the 25th percentile, so K will be 25. And then N is that it always is. N is the size of the sample. So the number of values in our data set. So that means that in order to find Q1, which is our 25th percentile, our locator value is going to be K, so 25th percentile, so 25 over 100 times N. We have 10 items, 10 restaurant receipts in our data. So 25 times 10 is 250, or you can think of it as 10 over 100. That gives us 10 on the bottom, so either way we get 2.5. So our locator value is L equals 2.5. So that means that our value that we want for the 25th percentile is between the second and third value. So we tend to round up, so we're going to go to the third value of our data set. So let's go back to our dot plot and see what our third value was. So the reason I come back to our dot plot is because in the dot plot our data was already ordered. So there's the first value, 38, the second value is 39, and our third value is 42. So that's going to be then our 25th percentile. So let's go back and write that down. So we can say Q1 is 42. So what this means that is that 25% of our data is below or is on or below $42 for restaurant receipts. And so we continue in this way. So Q2 is P50. 50. So what value gives us 50% of the data? We actually don't have to do a calculation here because 50% of the data is the median, is what splits it, right? The median is the middle value. So I don't really have to find that one. I can just look at my data from above and find what the median was, which was 45 when we look back at the top of our notes. So the median was 45. So that means that below 45, you have 50% of the data. Q3, we find it the same way, right? So we look at so that means P75. So we find our locator. So L will be 75, the percent that we want, divided by 100 times 10. So this will be 7.5 that we round up, sorry. So we look at the eighth value. So let's go back to our dot plot and see what the eighth value is. So the eighth value, and here, since I have it here, you can see our median calculation was 45. So the eighth value, so 1, 2, 3, 4, 5, 6, 7, 8. So 50 will be our third quartile. So I can say the eighth value of our data is equal to 50. Therefore, Q3 is 50. So that means that 75% of the data falls below $50. So that's what our quartiles mean. And so now that we have our quartiles, to find outliers, we have another formula. We'll need our inner quartile range. And so first we find all our quartiles, which we already did, and then the inner quartile range, or IQR, is equal to, and I'm going to highlight this because this is important, Q3 minus Q1. So in our case, the inner quartile range for our data is going to be, what do we have, 50 was our Q3 minus Q1. What was Q1? Q1 was 42. So that is our inner quartile range. So it's $8. And then 1.5 times IQR is going to give us the value for any outliers. So if we have any outliers above that, then or if we have any values above that, that's going to be an outlier. Or if we have any values below 1.5 times IQR below the first quartile, then that's going to be an outlier. So 1.5 times IQR in our case is going to be 1.5 times 8. And what is that? I get 14.4. So Q3 was 50, right? So then if there is a value that is 1.5 IQR greater than Q3, then that is an outlier. So let's see. If I do my IQR times 1.5, so let's do Q3 plus 1.5 IQR. This will mean we have 50 plus 14.4. So that will give me 64.4. Do I have a value in my data greater than this? No, right? Our maximum was 56. Our maximum data value was $56. So is it greater than that? No. So we don't have, so no outliers on the top. And then our Q1 was 42, right? So then if I do Q1 minus 1.5 IQR, so below Q1, so that's why I'm subtracting. So if I do 42 minus 14.4, what does that give us? And remember, our lower value was 38, so I can already tell, because 38 is only 4 below 42. Going 14 below that, this is not going to be, 38 is not going to be an outlier. So that means we have no outliers. I'll let you do the math on this. A quick way to see about outliers, so this is the mathematical, how to do it by hand, but if you go to let's go back to Statcrunch and let's look at the outliers that way. So here's our Statcrunch. So we're going to go to graph and box plot and restaurant bill. And with box plot, as we had mentioned in the prior video, or not prior video, but for the previous section, is really important to draw the boxes horizontally. So draw boxes horizontally and compute. And here is our box plot. If there were any outliers, they will be outside of the fences. So let me copy this into our notes real quick. Because one of the things that I want us to notice is our math and how it lines up with this. So here it is. So notice that we have our Statcrunch gives us our values. So notice that the IQR is 8, the Q1 is 42, so that's what we have found. Notice that we did our math, our IQR there is 8, right? Or Q1, we found it to be 42, or Q3, we have found it to be 50, or Q2 is the median, which is 45. Those are the data values. And so when we look at Statcrunch, notice that it tells us number of values, so that's the size of our sample, is 10. IQR is 8. The minimum value is 38. Q1, 42. Median, 45. Q3 is 50. So those are the same things that we did. Upper limit is 56, right? So that's the maximum. Now, this fences that we have here, this is the IQR, the big box. So this is our IQR. Now this is our 1.5 times IQR. So this is what tells us if we have outliers. So if you had any points out here, those will be considered outliers. So the fences, this little whisker, sometimes this is called a box and whisker plot because you have the box, that's your inner quartile range, and then you have the whiskers. And the whiskers tell you where the majority of the data is, and beyond the whiskers, you will have outliers. And so how did I get this yellow box on Statcrunch? Let's go back to Statcrunch. You just hover over any of the lines and notice that it pops up. You hover over any of these lines, then your information will pop up. You get the IQR, the first quartile, the median, which is also the second quartile, and the third quartile. So the box plot is really nice. It gives you lots of information. If you do the box plot for our Verizon data, as we were doing in the last section, remember that we had outliers. And so it will be a good exercise to go back to the Verizon data and try to find this manually, and then you get practice doing it mathematically, and then looking at the graph, it makes a little more sense. So I hope. Okay, so the main ideas here is percentiles divide the data into 100 equal parts. Quartiles divide the data into 4 equal parts, but a quartile, the first quartile is still a percentile, right? The first quartile is P25, 25% of the data. And to find a percentile or a quartile, we need the locator value, the position of the value for a specific percentile. So the position meaning in an ordered data set. L gives you where in the data set is that value. So for our first quartile, we found it to be, our locator was 2.5, so we rounded to 3, so the third value in the data set. For our third quartile, 75% of the data, we found our locator value to be 7.5, so we rounded to the 8th value, so which was 50. Right, when you go back and look at the data, it's $50. So below $50, you have 75% of the data. And then your quartiles. So I encourage you to play around with Statcrunch on your own. I want you to perform the EDA and draw a box plot for the airport data speeds for Verizon. Find the mean, range, standard deviation, Q1, Q3, and the IQR. Try to do it by hand first, finding the Q1, Q3, and IQR, and then double check with Statcrunch. I don't want you to do the standard deviation by hand because if you remember the Verizon data speed, it was 50 values in the set. So we don't really want to do these, right, or deviation in this formula for 50 values, which is one of the reasons we're using statistical analysis software like Statcrunch, so that we don't have to do these manual calculations for large data sets. On your notes, you have all those little boxes that have the instructions for Statcrunch. So make sure that you're paying attention to those. And on my lab, you should also see some Statcrunch tutorials, but email me if you have any questions.